just to begin, I have a scene here, and there's a game object here which contains a script that we will be running the different examples on, and then this console, I'll be writing the things out on the console. So that's quite simple. So let's go to the script. So in the script, just to start, I'm going to say that there are two ways, at least that I'm aware of, to start a coroutine. So one way is by calling the string name of the method. So for example, over here we have a coroutine, and then to call this one, we copy the name of this and write it as a string. And the problem that I have with writing them in as a string name is the first part is that we cannot pass in more than one variable into the function. So for example, the second one over here, which we call by calling the coroutine directly, we can pass in the parameters for the coroutine directly inside here, and you can have as many as you want. But with calling it by the string name, you can only pass in one. So I prefer, I think most people would suggest to use this method rather than calling it by the string name. Also, when you call it by string name, the reference in your IDE usually doesn't show up. At least it doesn't on my VS Code. So if you're using VS Code or something similar to this, then it may not show up, and then sometimes it makes it harder to debug or just navigate throughout your project when you have many lines of code. Well, we have a very simple coroutine which calls, so the first one is called coroutine 1, and then that will be calling 1, and then after waiting 2 seconds, it will be calling coroutine 2. So when coroutine 2 starts, it calls this. Maybe I should move this below so that we can, okay, wait. That, and then I'll add one more to show that coroutines end. Okay, so this is the easiest method of calling something, and you can use this when you have a situation where in a game or whatever you're making, you don't really care about what happens in between or the timings of when this happens. You only care that it starts at the end of a certain other behavior defined by another coroutine. So if we go back to Unity and we can test this out. So over here, I just need to press play, and as we were seeing here, so called 1 should be called, and then after 2 seconds, there should be called 2, and then after that, the coroutine's end should be printed on the console. So let's check. So there's called 1, 2, called 2, 1, 2, and yeah. So you can see that this works completely normally. Okay, the only thing I would maybe say, I would point out that you might want to keep in mind is, for example, when you start a coroutine over here, when you stop coroutine 1, after it has already started coroutine 2, even if you stop 1, this will continue to run. So this second one should continue to run. So with this situation, we will call start coroutine 1, and then we will stop it. In fact, let's move this to the end of that. So we will stop it. So technically, we should not see this happen because it will be stopped before the wait is done. But on the other hand, coroutine 2, because it was called before it is stopped, and then it is stopped after that. So it should call up to here, and it should continue because we do not separately stop this coroutine. So there's another method which is stop all coroutines, which would stop all the coroutines relating to this script. Okay, so now it should work. So call 2, and then coroutines end, and you don't see called 1 anywhere. So that is being stopped over here by the stop coroutine. Okay, so another thing that you can do inside a coroutine that has somewhat to do with chaining a coroutine is you can wait for another coroutine. So for example, let's see. So we have called 1 here, and then we can do yield return start coroutine 2. So what's happening over here is let's remove this one, call it print coroutine 1 end. Okay, so coroutine, let's change it to 2 end. Okay, so like this, what should be happening is we call coroutine 1. This. Okay, so we call coroutine 1, and then this will start coroutine 2, but it will also wait for coroutine 2 to end. So it has to go through the entire thing, and when it's finally done, it will finally come back out and continue with the coroutine 1. So the expected behavior over here should be something like called 1 followed by a called 2, and then coroutine end. Oh my gosh, you cannot type coroutine 2 end, and then finally coroutine 1 end. Let's try it out. And so we get 1, 2, and then 2, and then 1. So that's what I was saying. 1, 2, 2, and then 1. Yes, so it is correct. So that is another way that you can not only call, but you can even wait for something to end inside the coroutine. Okay, so those are I think the simplest ways to do things, but you could try to have more interesting ways to call coroutines, such as in a queue. So what I mean by that is, let us say we have, well, what we can do over here is, for example, let us say that we have a coroutine, and there are different objects that want to call that same thing, but then you can't have it stacking on top of each other. So you want it to be called in a queue, quite simply. So for that, we can build a controller which will be running on update in our case. In your scenario, you can change up how all of these work, but in this case, I will be using update. So this will be the controller method. So over here, let's make the controller. And for this, as we were saying, we need a queue. So let's make a queue. Queue of we can say usually an enum would be good. For what I mean by that is, so right now we have a coroutine 1. Let's just say we have a coroutine 2 as well. So start 1, and I'm sorry, start 2, and then end 2. So we have coroutine 1 and then coroutine 2. So these could be wildly different methods inside here, but in my case, they're basically the same. It's just 1 and 2. So we can have basically a queue of these things that we want to run, and then we need to know the order of which they were inputted into the queue so that we can use that the controller can use that to call them in the correct order. So let's make an enum, because then it makes it very difficult to go wrong later down the line instead of just using strings or something. I mean, you could definitely use strings, but we will start with enum. So let me just type that code out. Okay, so I've changed the code a little bit, and so basically what we're trying to do is at awake, we want to call 5 different coroutines at the same time. So that, just imagine something like a debuff in a game that the enemy gives to the player, but suppose that the debuff cannot be stacked. So then if you want to have the time to be extended, there are other methods of doing this, but just as an example from the top of my head, you can use this kind of method to add the time, sort of like have a coroutine that stacks on top of each, not stacks, but that gets queued up, that can be called in sequence. So what we're doing over here is right at the beginning, we want to add 5 different coroutines to a certain queue, and I will go through this method in just a second. But so usually if you just start 5 coroutines like this, they will all run at the same time. So if they wait 2 seconds and then print something, then they will all print at the exact same time. So after 2 seconds, all 5 of them will print, instead of waiting 2 seconds printing and then the next one will go 2 seconds and print, and so forth like that. So instead of doing that, we can make a add coroutine method, which will take an enum, as I was saying earlier. So we've defined it here just so that we don't mess the names up or the methods up. So the add coroutine, all it does is it takes the coroutine queue, which is a queue that we have made up here, and it will unqueue the correct the enum that you wish to put in there in the queue. So after that, what happens is the controller, which is being called every update. So the controller I just called, it's a method. So what happens is, while a coroutine is not running, so that we made a bool separately for this, when there's no routine that is running, and while there is something that is queued up, so the count is greater than 0, then we will make it a true so that we cannot run another one while something is running, and then we will start the corresponding coroutine from the queue. So we will remove the first item of the queue. So this is over here, and we pass it into over here. I made a different function where here we basically sort through all the different types that we have and start the corresponding correct coroutine. So over here, because I only have 2, I made it very simple. Of if it's 1, then we start coroutine 1, otherwise we start coroutine 2. And the 2 coroutines here are just over here, the same as before. They have the start, and then after 2 seconds they will call the end. So coroutine 1 does not have any numbers, but this coroutine 2 has the 2s at the end of it. Also, I added the routine running is equal to false, so that the coroutines themselves will set the routine to false, and then that will allow the controller to move on to the next coroutine. So the expected output over here should be basically this will be added to the queue, and basically all of these will be added to the queue in sequence. And then starting from here, because this was added first, it will be popped out of the queue and be called. So when it is coroutine 1, we'll have the start and then end for 1 for coroutine 1, and then we will have that one more time, the same thing, this, and then it will be the start and end for 2, and then start and end for 2, and then for 1 again, just in the same order. So we should expect to have a 2-second wait between each of these prints for the start and the ends, because we have a wait for 2 seconds on each of them. So let us test this. So if they all, we are hoping that they don't all start at the exact same time. So let us go, and as soon as Unity compiles, we can start it, and let us check. So we have start, end, and start 2, once again 2, and then start 2 again, and then we have the final end. So we can see there are 10 calls, and there were 2 calls for each coroutine. So it makes sense. So the first one called the start and the end, and then start and then end, and then the coroutine 2 called start, end, and then the last one was once again a type 1 coroutine. So we got the correct output over here. Of course, this is a very simple example. In your game, the general idea over here will probably be the same, but then obviously the logic inside here and mainly in your own coroutines will probably be vastly different from what I'm doing. I mean, what I've shown over here. Okay, so I think in most cases where you just want to sequence coroutines and you don't really care about the exact timing of when they happen, except for the fact that they just happen at all, then this is completely fine, and I don't think there's any other reason that you may have to use some other way. Of course, if you know a better way, let me know, as I'm also always learning. But there was one other method that I actually was trying to use before I found this method out, and it's a bit complicated, so let me just prepare that. So for the other method, where we can use, we make a different separate class that can hold the coroutine as well as its key together. And over here, it's important that we wrap the key inside the class, unless the key itself is a reference type, because over here I'm using a value type, which is a Boolean. So if we end up just using the value type without it wrapped inside a reference type, which a class is, then you'll have issues, because value types, they don't they don't refer to the same object when you pass it in to, for example, the coroutine, which we will do up there, but they just make a copy of it. And so when you change it outside and you actually want to flip the switch for the coroutine to progress further, what will be happening is you'll be flipping the switch for the new key, which is not referenced by the coroutine. So by having it wrapped inside the class, which is a reference type, you can refer to the exact same key that would be over here. So the overall thing that we're doing is, so we have, first of all, as I said, the coroutine holder, which has a coroutine that we will start and then save it in here, and then the key that will hold to either stop or pause the coroutine. The exact details of this can depending on your can change depending on your situation, but in my case I just have a key, and each of the coroutines, they will be passed in a coroutine holder, and then the key over here, they will wait until the key becomes true. So initially it is false as default, and then it will be, when you turn it into true, then it will proceed towards the end of the coroutine. And so over here, the method I'm using is, first of all, we make a new coroutine holder, and then that will have the key, and then we start a coroutine and then pass in this holder, which means we pass in the key, and then we we save this coroutine back into the coroutine holder, so that we can now just pass around this coroutine holder to access both the key as well as the coroutine if you for some reason have to access the coroutine itself. So we can do that, and then what we can do is, in this case I just call it in the update, but in other cases you could have this coroutine holder passed around different objects, so for example different enemies or players, and then they, at whatever timing that they want, they can flip the switch to for the key, and then that will move on the coroutine to the next phase. So the advantage of this method over maybe the queue would be, you can start all of them, and like all the things that have to happen before you pause the coroutine over here, you can put in front, and then it will come and pause in this part. And in fact, you could even add more keys if you want to add more functionality, but then I think that would make it a bit complicated, but maybe you could do that. And in a way, I guess you could just make two separate coroutines where the first part would play whatever is at the beginning, and then you'd have some condition that will trigger the second part, given that the first part is done. But that is up to you, and but this is also another method that you could achieve a similar effect. So over here, we for both coroutine 1 and 2, we make the coroutine holders, which essentially holds the key as well. We start the coroutine and pass that back into the holder so that we can pass the holder around. Over here, we don't pass it around, but I just did it for the sake of completion. And over here in the update, after 2 seconds, we'll have the second holder key flipping to true. So this will show end 2 after 2 seconds, and then after 4 seconds, so over here we can I will turn the coroutine 1's key to true, and so this will also come out of the loop, and then we'll have end 1 printed after that. So we're expecting both of these, start and start 2, to print in the beginning, and then after 2 seconds we'll have an end 2, and after 2 more seconds we'll have end 1. So let us go to Unity and check that. Oops. All right, so let us try that. So we have start and start 2, and after 2 seconds end 2, and then after 2 seconds I end 1, and then after that there's nothing else because all the coroutines have ended. Yes, and that is all. Thank you for watching, and I hope that this was helpful.